Okay, Math 10, lesson 1.1. So factors, primes, composites, and multiples, yada, yada, yada. So, if we're given a problem like this, so if you were asked to arrange 12 chairs in the classroom, all different ways, right? So you could arrange it, this way, or you could arrange it like any one of these ways, right? Then what you could do is you could actually draw them all out, right? And figure out how many ways you could actually arrange that. But the other thing you could do is you could figure out what the factors of 12 were, and you could use those to figure out how many arrangements you actually have, right? So, go down a little farther here. The different factors, you can break this up. You can say, okay, a factor of 12 would be 2 and 6. So factors just mean like things that multiply to the number, right? So a factor of 12 is 2 and 6. You could also say 3 and 4, right? So 3 would be a factor times 4 would be 12 as well, right? So those are factors. Yeah, so now we can see, so note that these factors are another way to represent the ways that the chairs can be arranged, right? So we could have 1 times 12 to get 12. So that would be like as a picture, right? That would be this one. 1 times 12, right? Like 1 down, 12 across. Or we could have 2 by 6, right? 2 times 6 would tell there's 12 chairs in total. So you can arrange them that way. 4 times 3. 3 times 4. Like 6 times 2. 12 times 1. Yada, 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 right? So we could figure that out just from knowing this part of it too, right? So the factors of 12 are 1, 2, 3, 4, 6, and 12, right? Those are the numbers that you can multiply to get 12, right? So 7 is not a factor of 12. I can't multiply 7 by anything to get to 12, right? So that's the idea there. Okay, so can you guys find the factors of 36? I'll give you a hint. 1 will be a factor.
Are you sure about that?
So, factors of 36. So really, I'm kind of asking myself, if I go 36 divided by some of these numbers, will I get like a nice number out of it, right? Like if I go 36 divided by 5, I'm not going to get a nice number. I'm going to get a decimal, right? So that's not the one I'm looking for. But, so 1 works. What else? What's like the next one up? What else goes into 2, right? 36 is an even number, so 2. Next one. 3, yeah. So, yeah, because you can go 36 divided by 3. Next one. 4. 5? No. So just 6. 9. And 36, yeah. 36 itself, right? Yeah. So you say that those are the factors of 36. Okay? You know what? This one is a little time consuming doing it this way. I'm going to skip this one for now. I'll show you like an easier way in the next lesson. All right, find all the factors of 17. Yeah. Do you guys know what kind of number 17 is? I'm going to talk. It's a prime number, yeah. That's what a prime number is. It's only divisible by itself and 1, right? So that's it. So it's just 1 and 17. All right, common factors. You guys have been doing this kind of stuff quite often too when we've been doing fractions and everything else, but as a bit of a review. Okay, so determine the common factors of 12, 15, and 21. Okay, so what we can do, and this is the way we'll do it now, because the numbers are kind of simple enough, is we can just figure out all the factors that would give us 12, 15, and 21. So I could go 1 times 12 to get 12, 2 times 6, 3 times 4 to get 12. To get 15, I can go 1 times 15 or 3 times 5. And to get 21, I can go 1 times 21 or 3 times 7. So if I'm looking for common factors, I'm really just looking for the things that are common between them, right? So really, all that is, the one that shows up in all 3 would be 1 and 3. So those are common to all of those numbers, right? And typically you wouldn't say 1, because 1's really a common factor at all of them. It doesn't really do us any good. So, but yeah, technically it is. Okay, so primes, composites, and multiples. So prime numbers, I already kind of talked about that. Can you guys try this one? So number 4, identify all of the prime numbers between 2 and 20. Can you guys just circle the numbers that we think are prime numbers? Is 2 a prime number? Actually, it's just 2 in itself, right? You can't divide by anything to get like a smaller number. So yeah, 2 actually 2 is. People miss that one sometimes. 3? Yep, prime number. 4? 4 is not, because 4 divided by 2, right? I can get 2. So the factors of 4 are 2. 5? Yep. 6? Yep. 7? Yep. 8? 9? 10? 11? Yes. 12? 13? 14? 15? Oh, what am I doing? 16? 17? 18? 19? There you go. There's our prime numbers. So you can kind of see the general trend of these things too. As they get as we go bigger and bigger, they get kind of spaced farther and farther apart as you're going up too. It's kind of a bit of a side note, but there's entire branches of mathematics that are dedicated to finding like the next prime number. So I don't really understand it fully, but apparently it has like a lot to do with encryption. So like finding the next prime number would make it so that your phones were way more secure than they are right now, or that some computer database is way more secure. Yeah.
My dad actually, for his coding, he actually does have to do the numbers with that.
Yeah, ask your dad about prime numbers, because I know that's a big part of encryption in technology, right?
I watched him one time and he was like...
Okay. So composite numbers. So do you guys know like a composite hockey stick? You ever heard of that? I guess they're all composite sticks now. You probably don't know the difference. Composite means like made up of many things, right? It's made up of like a lot of things. Same with composite numbers. That just means that they're made up of like multiple factors, right? So an example of that would be like 8. So 8 could be 1 times 8 would give me 8. 2 times 4 gets me to 8. So this one, the factors here of 8 are going to be 1, 2, 4, and 8. So 8 is a composite number. That make sense? Yeah. So yeah, not a prime really. So is 18 a prime number or a composite number? Composite, right? Because I could go 9 times 2. I can go 6 times 3. And 18 times 1. Yeah. Really, those are the yeah, these are our factors though. I don't really need, because 6 times 3 is the same thing as 3 times 6. Yeah. All right, we'll actually skip a couple of those too. So multiples. So a multiple of a number is the product of a given number and integer value other than 0. That sounds confusing, but multiples is kind of what it means. So like multiple, if you went 5 times 2, and then times 3 times 4 times 5. So that's that integer value other than 0. That's pretty much it. So it's like 5, 10, 15. It's like counting up by the number, right? Those are multiples. Yeah, so find the first 6 multiples of 13. So first one's 13. What would the next one be? 26. Yeah? Yeah, so give that a try. So we got 13, 26. What's the next one? What's the next one? Next one? Next one? 70. Okay, cool. There you go. First 6 multiples. Okay, so then just the last thing here. This example says find the first 3 common multiples of 12 and 18. So in the next lesson, I'm going to show you guys how to do this without writing out every single one, right? For now, for this first lesson, all we have to do is like just write them out like we just did, and circle, or they're just highlighted on the page here. But if you wrote out 12, 24, 36, 48, right? And then 18, 36, 54, and go up like that, we can see that there's places where you land on the same number. So that's a common multiple. Okay, least common multiples. Yeah, or I guess that'd be the least common multiple. But then there's other multiples as well. Okay. All right, so that's it. It was quick and easy for the first one.